Hello, we are going to do a problem, two-dimensional problem for kinematics that's not projectile motion. So in this problem, we have a boat that is sailing eastward at a speed of 5 meters per second. A sudden gust of wind gives the boat an acceleration of 0.8 meters per second squared, 40 degrees north of east. What are the boat's speed and direction 6 seconds later when the gust subsides? Okay, so let's take a look at this. So I'm drawing my picture here, right? So here is, I'm saying this direction is east, and this is north. And this is my nice boat moving along in the east direction at 5 meters per second. And then the wind here, right? This is the wind. It's blowing it at a direction 40 degrees north of east. Okay, so that's my north and east directions. So when we want to go through solving our problems in 2 dimensions, we also want to create an x and y origin, right? Because that's usually what we're working in. So I am going to, it doesn't actually matter exactly where I put it, but I'm going to put it right here. We'll say that this is our plus x direction, and that's my plus y. Okay, and then let's get ourselves organized here. So this is different in that this is our acceleration is given at an angle, right? So in projectile motion, we've seen initial velocity at an angle. Here we actually have acceleration at an angle. So we know we're going to have to break that into our x and y components. So let's do that first, and then we'll gather up the rest of the things that we know. So we have our acceleration vector. It looks like that. It has a component in the x direction, ax, and it has a component in the y direction, ay. And we know that angle theta is 40 degrees. So again, we go through our trig functions. Here's my angle theta, my opposite side, sine equals, sine of theta is my opposite over hypotenuse, that is ay over a. So ay equals a sine theta. I can do the same thing for my adjacent side, and I get that cos theta is ax over ay, just over a, and then ax equals a cos theta. Okay, so if I plug in 0.8 for my acceleration, meters per second squared, and then the sine of 40 degrees, and then over here, I'm going to do 0.8 again, meters per second squared times cosine of 40 degrees. And I did calculate that out already, so I got that this is 0.613. I'm just going to keep 3 significant figures for now, meters per second squared. And ay is 0.514 meters per second squared. Okay. So that was just kind of a necessary step to get things split up correctly into x and y. So now we can look at our variables. So what do we know in the x direction? What do we know in the y direction? So this question actually doesn't ask us anything about position. When we can kind of put them down there for just completeness, x0, x final, v0 x, v final x, and ax. And then do the same thing for y. We don't actually know this or need to know the position information, but we'll put it there just for completeness. v0y, v final y, and ay. Okay, so these we don't know and don't need to know, so I'm just going to put a line there. v0x we do know, that's here, 5 meters per second. The final y we need to find because it asks for what the final speed and direction is. Now we know what ax is, that's 0.613 meters per second squared. Okay, v0y we know because it says it's just moving in the x direction, right? It doesn't have any component in the north, so that's 0. V final y we don't know, and then we do know that the acceleration here is 0.514 meters per second squared. Okay, so this is what we're given. And then we want to find speed and direction after 6 seconds. Okay, so this is good in that it's pretty different from the other problems that we've seen, which have focused more on like position of things. So in order to find the speed and direction, we need to know what the final velocity is in the x direction and the y direction. We'll combine them back together to get the speed and direction. Okay, so the equations that we're going to use, right, are the velocity equations. So v final x is v initial x plus axt. And then we have the same thing for y. V final y is v initial y plus ayt. Okay, and then we can cross out anything that's 0. So v initial y is 0. That goes away. And then let's just plug in. So we have v initial x is 5 meters per second. So we don't need to do any algebra, right? Because we already have these equations in terms of what we want to find. So 5 meters per second, and then our acceleration is 0.613 meters per second squared, and our time is 6 seconds. So that will give us a final x velocity of, again, I calculated these out already, so you guys can do that as well, 8.63 meters per second. So that's an important piece of information. I'm going to put a little box around it, and then we'll divide my x and y. So v final y is going to be my acceleration in the y, 0.514 meters per second squared, times time, which is 6 seconds. And if we calculate that out, we get 3.08 meters per second for v final y. Okay, so we're getting close. Now we just got to combine those back together to get the magnitude of the velocity, which would be the speed, and then the direction. I don't even know what that says, direction. Okay, all right, so this looks like, if I just draw out my vectors, and you always want to do this, right? So we can have a long one for v final x, because that's 8.6. This one's shorter, right? Just 3.08. So that would be v final y. And then that's v final. Right, the hypotenuse of that triangle. This is my right angle. So I can use Pythagorean theorem, and I get v final is the square root of v final x squared plus v final y squared. And that will be the square root of 8.63 meters per second squared plus 3.08 meters per second squared. And if I take the square root of that, I get 9.16 meters per second. Okay, so we are almost there. We just need to get our direction, which would be theta. And so tan theta is opposite over adjacent, so v final y, v final x. Tan theta is v final y over v final x. And then if I take the inverse tan of both sides, I get that theta is inverse tan of v final y over v final x, which I can plug in now, inverse tan. V final y, we said, was 3.08 meters per second. V final x is 8.63 meters per second. My units cancel out, which is good. And if you calculate that, I got theta is 19.6 degrees. And that's that. So pretty good, right? So just for my presentation, right, I have my picture, I have my coordinate axis, I'm showing my work for breaking up my vectors, I write down my list of what I'm given, what I need to find. I started with a general equation. I didn't need to do any algebra first, so it's okay. I have my answers that I'm boxing, making sure that I've propagated my units all the way through. Another diagram for showing how I combine my velocities at the end to get my final velocity, speed, right? Just the magnitude of velocity and the direction. I would give myself 3 out of 3 on presentation.